Now, whatever method of estimation you apply to these two series, they have a long run correlation, so it will be valid. Now, if you want to choose the error correction model, you can choose. If you want to do any other kind of analysis, you can also do, because these two series are related to each other in the long run. They are co-integrated. Now, any estimation methodology will work. There are many options and we will go into the details. Let me complete this first. This was your, as I have said you, there is Engel-Granger procedure, and this is step 1 of your Engel-Granger procedure. What is step 2? Step 2. The step 2 is estimate ECM, error correction model. What is the error correction model? This is model like this. Del yt is equal to beta 1 del xt plus beta 2 ECT and t minus 1. This is your error correction model. So, I will estimate the error correction model for this data. Look, I have in this data set L cons and LGDP, but the model that I will estimate now is containing del xt and del yt. I am not having these series. I will generate these. How? I will go to calculator and I want to take the difference of these two. I am selecting them simultaneously because the two series are to be applied with same operation. Then taking difference, its first difference, okay. The proposed name is DL GDP and DL consumption, okay, and then close. The two new series are generated, DL cons and DL GDP. These are to be used in the error correction model. So now what to do? Again go to estimate, and I am using time series models, and then single equation dynamic model, formulate. I have to take DL consumption as the dependent variable and DL GDP as independent variables. These terms are not to be included. Then error correction term, and you have to include only leg of error correction term, not the current value. This is finally, the constant is also not to be included. This error correction equation does not have a constant. This is your output. What this output says, if there is 1 unit change in the consumption, in the difference of consumption, DL consumption, there will be 1 unit change in the DL GDP. It's actually reverse. If you have 1 unit change in DL GDP, there will be 1 unit change in DL consumption. And then you have ECT term, and the coefficient of this term is negative. This ECT term is the error correction term. I have explained this. This basically says if you have long run relationship and there is a deviation from the long run path, this coefficient will drive the relationship and this will bring the series back to the long run path. If you are above the path, next time this will compel you to the lower level so that you can come back to the long run path. So this coefficient should have negative sign. If this is positive, then theoretically there is no chance of cointegration. So that's it. Now, if you look at this model, you will find that if you look at this output, which is visible to you, this is AR12 test. This is test for autocorrelation. This is test for autocorrelation. The null hypothesis is no autocorrelation, and this is the test statistics. This is the p-value. The p-value is larger than 5%. This means the null hypothesis of no autocorrelation is not rejected. This is arch effect test. This is a test for arch effect, and the null hypothesis is no arch effect, and this hypothesis is also accepted because the p-value is large. And then there is normality test, heteroscedasticity test, and then at the end you have reset test. There are two forms of hetero test. One is simple hetero, and then other is hetero X test. So all of these tests are saying that there is no problem of heteroscedasticity. So at this point you will end. Right? This is giving you the short run parameter, which is 1.01. This is short run elasticity of the consumption with respect to income. And then there is another short run parameter which is minus 0.145, and this is the adjustment parameter. This is the parameter which will bring the series back to long run path. But it is, you might have listened that the error correction model is containing both long run and short run parameters. So where are the long run parameters? The long run parameters are built in the term ECT. What is ECT? Basically ECT, from where ECT is coming? ECT is coming from this equation, the epsilon is, right? So ECT is equal to epsilon t. This is yt minus alpha minus beta xt. Because you have estimated, you can put hat over here. These are your long run parameters. These long run parameters are built inside the term ECT. These are not explicitly visible. So where are these parameters? These parameters are 1.01 and minus 0.14. Now, the question from Mubin is, what is the range of adjustment parameter? It is negative. A negative means you can have any number. Yes, you can have -2. Right? This is how you can do the co-integration analysis.
Comes from the equation 1, first equation, alpha naught and beta naught. These are the parameters of equation 1.
Yes, please. You have rightly pointed out the long run parameters are coming from the long run equation, which is not containing any difference and not containing any lag. That equation is here and the long run वो कहाँ पे है, इससे भी ऊपर है, ये वाली. The long run parameters alpha is equal to -0.32 and beta is 1.002. These are the long run parameters. ठीक हो गया? Co-integration समझ आ गई? Did you understand co-integration, Tumani? Okay, so the next question is, there are many tests of co-integration. Which one should be applied? Everyone is having a different kind of methodology. What I believe, there is no need of